One night you look up and it's just gone. No explosion, no warning. The moon that's hung over every single night of human history simply isn't there anymore. You'd probably just think it's a weird trick of the clouds. For the first few hours, almost nothing would seem wrong at all. That calm wouldn't last, because the moon isn't just a pretty light in the sky. It's been quietly running half the systems that keep life on Earth stable. Let's start with the most obvious thing the moon does. Tides. The moon's gravity pulls on Earth's oceans, and as the planet spins underneath that pull, water rises and falls twice a day. Take the moon away, and tides don't disappear completely. The sun still tugs on the oceans too, but they'd shrink to about a third of what we have now. That sounds harmless, until you remember how much life depends on that daily rhythm. Tide pools, mangroves, entire coastal food chains are built around water moving in and out on a predictable schedule. Break the rhythm, and you break the ecosystem's tune to it. Ocean currents would shift too. Tidal mixing helps stir nutrients and oxygen through the water. Without it, parts of the ocean would grow stiller, and stiller water is less hospitable to the life swimming through it. Here's the part almost nobody expects. Earth doesn't spin perfectly upright. It's tilted about 23.5 degrees, and that tilt is the entire reason we have seasons. What most people don't realize is the moon acts like a stabilizer. Its gravity holds that tilt fairly steady over long stretches of time. Without the moon's pull, scientists who've modeled this, most famously a study led by astronomer Jacques Lascar in the 1990s, found Earth's tilt could start swinging wildly, potentially anywhere from nearly 0 degrees to over 85 degrees, over millions of years. A tilt that unstable would mean seasons stop being seasons. Instead of predictable summers and winters, regions could swing between extremes over geological time. Ice sheets creeping toward the equator in one era, blistering heat replacing them in another. For anything trying to survive on a fixed cycle, plants that bloom on schedule, animals that migrate by season, farmers planning a harvest. A wildly unstable climate is far more dangerous than a slightly weaker tide. There's a simpler change, too, one you'd notice almost immediately: true darkness. Right now, moonlight, which is really just reflected sunlight, is the brightest natural light in our night sky by far. Take it away, and nights get dramatically darker. On clear nights, you'd actually see far more stars. But for nocturnal animals that rely on moonlight to navigate, hunt, or avoid predators, that darkness would upend everything. Sea turtle hatchlings are a well-documented example. They instinctively crawl toward the brightest horizon, which under natural conditions is moonlight reflecting off the ocean. Coral spawning cycles, time to moon phases in many species, could also fall out of sync. Even human history would look different. Before electric light, moonlight genuinely shaped when people traveled, hunted, and gathered. It's a small thing that touched almost everything. Now for the strangest part. The moon has been slowing Earth's spin down for billions of years through something called tidal friction. Basically, the drag created as the moon's gravity tugs at our oceans. Billions of years ago, a day on Earth was only about 6 hours long. The moon has been gradually stretching that out ever since, and today we're at 24 hours. Remove the moon, and that break comes off. Earth's rotation would gradually speed back up over a very long time scale, meaning days would slowly get shorter again, not longer. It wouldn't happen overnight. This is a change measured in millions of years, not headlines. But it's a strange reversal of a process that's been running since before life even existed on land. So here's the strange conclusion. The moon rarely gets credit for any of this. It doesn't grow anything, doesn't breathe, doesn't do anything dramatic. It just sits there, 384,000 kilometers away, quietly doing its job. But pull it out of the picture, and you're not just losing a pretty object in the sky. You're removing one of the steadying hands that's been keeping Earth's tides, tilt, and rhythms in balance for over 4 billion years. So the next time you glance up and see it hanging there, half lit or full, it's worth remembering. That quiet light isn't just decoration. It's one of the reasons everything down here still works the way it does.